Just want to thank you guys for coming out, those of you who showed up. Big thanks to all of the co-sponsors for making it happen. Without all of them, this wouldn't really be possible, and I wouldn't be giving this talk, nor would any of that delicious food be sitting in our stomachs right now. I'd also, just before I get in, like to give a big thanks to Kristen Teal from Lakekeeper and Vacamo. A lot of his source material online heavily contributed and inspired the contents of this talk. Big shout out to him. They have their own REST catalog implementation. And it allowed me to get into the nitty-gritty details about this. But with that out of the way, I'd like to discuss maybe the state of REST catalog security, where it is now, where it's going. I will say this topic is a little bit esoteric. You have to go digging. Every single provider of a REST catalog implementation has their own cryptic terminology, and people are mishmashing authorization, authentication. People go crazy. But hopefully by the end of this talk, you guys have a little bit of a better understanding of where we sit in REST catalog security, what the state of it is now, and where it's going. So let me jump into it. So I titled this talk, Who Gets In? Securing the Iceberg REST catalog. So as for the agenda, talk about what the REST catalog is, why secure the REST catalog at all? What's the point? Some challenges in security, strategies, architectures in REST catalog security, and then that's going to kind of close out with some best practices. So a little bit about me. I spend most of my time educating and empowering developers within the StarRocks and Lakehouse ecosystem. Previously worked in financial services as a data engineer on the sell side. At an investment bank where I was working on execution engines, order management systems. So kind of the whole stack was part of my wheelhouse of Java, Kafka, AWS, you kind of name it. That's just a little bit about me. I'm always willing to talk about the markets after the talk. So what is the Iceberg catalog? What is it? Well, it's the front door to your Iceberg tables. I figured maybe mention what actually the catalog does. Basically, it's answering the question, where is this table X, and what is the metadata responsible for that table? So at its simplest, that's really all it is. If we want to look at it kind of like a phone book, that you could think of it that way as well, but it really has a metadata pointer to the most recent metadata for all of your tables. And to go into some history, when the catalog was first established, it started with Hive, as Hive kind of predated Iceberg. And expanded out to Glue, Nessie, JDBC catalogs. But the main issue with the expansion was that for every catalog implementation, you kind of needed a different client library and set of dependencies for each of that catalog. So if I was a user who just really loved using Spark, and I liked using JDBC, and my friend liked using Spark and Glue, well, we'd have to probably write different code, probably have different implementations for this engine catalog combination. And ultimately what happened was this became a combinatorial issue where you had N engines and M catalogs. So N times N different interpretations of what a catalog means for that engine. So some smart folks in the Iceberg community got together and said, okay, maybe there's a better way to approach this subject if all of our vendors are creating their own way of doing this. Could there be some sort of universal spec to solve this issue or this combinatorial issue that's causing everybody a headache? Because we don't want the spec to diverge. And the answer was yes. We could implement a REST API spec. This is, of course, a language that the majority of internet users and browsers talk. And a REST API spec could expose HTTP endpoints that in a single configuration that is universally understood by programming languages and browsers. And now we didn't really have to reinvent the wheel for every engine and catalog. So we got standardized operations, and these endpoints allowed for a headless environment that everybody could work with. It was language and engine agnostic, and it was lightweight now. You didn't have to have, say, for example, some crazy thrift dependency or some crazy broker or tool set built into your Iceberg with your catalog to manage any of this. So we saw the likes of Gravitino, Lakekeeper, Nessie, Polaris come into play. Nessie and Polaris kind of are merging now. But we kind of saw these players come into the picture with their own REST catalog implementation. And so then my next natural question is, why would you even care about securing the REST catalog at all? Like, what is even the point? Who cares? What's at risk? That's, I think, the more important question. Well, I think it boils down to 3 principles. The first one is compliance. If somebody gets unauthorized, unfettered access to your REST catalog, they can list all of your databases, they can list your tables, schemas, find the exact path and location of where your data sits, where your columns sit. Very sensitive information. And living in an age where we have GDPR, SOC 2, HIPAA, depending on what industry you're in, if you don't secure your catalog, then you're kind of putting yourself at a massive risk for failed audits, fines. You're basically giving away the kings of your data kingdom to whoever happens to come upon it, which these days are a lot of people. A second one being multi-tenancy. So what do I mean by multi-tenancy? Well, a lot of organizations these days, whether it be catalog, REST or not, they run one catalog that serves multiple teams, a multi-tenant setup, right? You may have marketing team or maybe like a QA team or developers, business intelligence. They might be using the same catalog. If we don't enforce isolation, team delegation for credentials, or say, one catalog from the marketing team is safeguarded by some query threshold, then you're giving room for compromisation internally as well. And the last one being multi-layered security. This part I think is important because your security doesn't really end at the catalog level. It's kind of multi-layered. There's one level which is the storage layer. So say you're sitting on a cloud like GCP or AWS. You may have an IAM permission, permitting users to access your S3 bucket at this location or URI. That's just one aspect of security. You also have to secure it at the metadata level. Because if you expose one aspect and you lock down the other, you're leaving vulnerabilities. So for example, you might say, hey, I set the IAM permissions for this S3 bucket. Why does it matter if they can use my bucket? Well, okay, they might be able to, still see the path of where your tables are sitting. And now, somebody who wants to get into your system, they might not be able to access the data, but they kind of know the file path and they know where to attack if they need to get your data. So this is kind of a multifaceted kind of risk profile that we have when we're looking at not only just REST security, but Iceberg security and at the REST level in general. Now, what are some other challenges that we have in REST security? So the first one being is how do you authorize, and this will kind of segue into kind of what we're discussing now. How do you authorize multiple query engines to gain access, and how do you differentiate query engines and privileges from the individual users behind the screen? Because the authentication and the authorization protocols that we use are designed for machines and for users. So we need to figure out how to differentiate that. And how do you differentiate fine-grained control? Like how do you differentiate between table level permissions versus column level, that sort of thing? And then the credential lifecycle. How do we expose credentials to the user or query engine to use? And what's their time to live? Am I generating like these token refresh or these refresh tokens? How long are they living for? And then you kind of have the multi-cloud complexity. So how do I do this across multiple clouds, right? So now to that, now that we've kind of looked at why you would secure your catalog, what are some challenges and issues within security itself, whether it be REST or not? What are some strategies and patterns that are in REST security today? So let's take a look at this. So over here I have machine-to-machine clients, and I have a few things set up here. So I'm going to specify, what is the status quo right now for REST catalog security if you're just, say, executing a Spark task with an Airflow job. It's a machine talking, some API call being made. At the top, on the top left, I have examples of some identity providers. Could be Ping ID, could be Keycloak, could be Okta. On the right-hand side, I have some examples from some REST catalog examples, Lakekeeper, Nessie, Bottom right, I have a S3 bucket representing object storage. And then on the left, I have the Airflow and Spark. So I'll be using this model for the next 3, 4 slides, changing up who the actors are. But machine to machine. Before jumping in, I just want to clarify as a refresher. I guess who is familiar with OAuth or OpenID in general? Raise your hand. OK, all right. I figured that's why you're attending this talk, right? So just as a refresher, OAuth, it's an authorization tool. It's not an authentication tool. OAuth plus OpenID gives you authentication and authorization, respectively. And it's kind of been misused in the past, the terminology, but I want to clear that up. Traditionally, the two flows we would see in OAuth nowadays, there's some older forms like implicit flows, which aren't really as used anymore, but we have client credential flows, and we have authorization code flows. And these are the different ways we can authorize entities. So let's say, in my example, I have a Spark task that's executed via an API call with Airflow. It's stateless. There isn't any human user involved, right? It's just a machine, it's a script. In this case, what we would leverage is a client credential flow or a JOT bearer token flow. And what that would mean is I would log in with my Airflow job. I do a post request to the identity provider and say, OK, here, I'm going through the client credentials. I'm using some sort of Spark service account, and I'm exposing a secret key as well to you. So I have the client ID, and I have the client secret. And I'm exposing these two things for you. And in return, I receive a JSON token. And this token could be in a JOT token format. It could really be in multiple formats. But at the simplest level, it's a JSON token. And this is telling me, OK, yes, I see that you're some machine user. I'm going to give you this token for access. And then after I get this token, I can do a GET request on my REST catalog and say, hey, I'm a machine. Take this token. I'm verifying that I exist. And then the REST catalog will go ahead and validate the token with an identity provider. And then after it does that token validation, it'll return back to us, the machine, some set of vended credentials. And these vended credentials are basically storage credentials that have a specific time to live, or you could also refer to them as refresh tokens, let's say 10 minutes, 5 minutes, that allow us to then access and retrieve our object storage. So this is, as of now, this is pretty heavily implemented. Client credential flow in the context of machine users is pretty extensive. This is used, and it's used by a lot of the big REST players that I mentioned here as well. How does this change a little bit differently? I mean, I can talk about machines all day. How does it change when we actually have user clients? Or let's say we have a Python script or a Jupyter notebook, and I'm filling out my, creating my Spark session. I'm kind of initializing my code. How would I go about doing that instead? So this, let's say I have, I log in again with my Python client or Jupyter notebook. What's a little different now is instead of using client credential flow, I'm not a machine anymore. I'm a user. So I can leverage an additional layer or abstraction of authentication we wouldn't get otherwise. And that would be authorization code flow. Now, what would happen here is I log in, and instead of immediately exposing my client ID and my client secret, what instead can happen is I can expose a backport locally or wherever I'm hosting, let's say in this case localhost 8080, and get an authorization code back. And then once I get the authorization code, I execute the authorization flow, which, OK, now through a back channel or a secured server on the back end, I can send the authorization code back to my identity provider. And a couple fields there we'll see, like grant, in this case, it's not client credential, authorization code being sent, example ABC, 123. And it's mentioning the redirect URL that I received. So this is kind of the additional layer of security, where now I'm getting an authorization code, and I'm also verifying myself as a user this way. I'm not a machine anymore. That's the main distinction. And so then I get a user token, and then receive it back at the notebook level or the Python script level, whatever. IDP says, OK, that's great. Here's your user token. You're allowed to use this now on your catalog. I do the same kind of GET request again on my, whatever my REST catalog is, validate the token. You guys kind of get the message. It's similar to the last one. Get some vended credentials. And then I retrieve the data from my bucket. Now, this is kind of what I've shown you. Now, where it gets kind of interesting is when you have query agents. And here, this is where the spec is kind of open-ended right now in the Iceberg community. This is kind of what the meat and potatoes is for a lot of what we're, are interested in. I mean, query engines these days. Query engine clients, they fall under two types of permission enforcement. So this first one is compute enforced permissions. And we're going to get into that in a second. But for basically easier implementation, query engines, in a lot of cases today, they still implement client credential flow. But if we pause a second, you'll notice I just said that machines use client credential flow. But behind query engines, there's still users. So technically, we can't really use client credential flow because, well, we'll see in a second what the implication of that is. So let's say we use client credential flow. I get back a JSON token. But now I'm passing the token as a super user. There's no user really in there. I'm not using authorization code or anything. And a lot of query engines and catalog providers kind of do this because, well, implementing some other stuff I'll talk about briefly is harder to implement. And this is usually the most straightforward way. But there's some nuances to this that we don't really want. So the caveat with this is that, OK, let's say I pass the token as a super user. I validate again. I validate maybe against some open source permission system I might have, vendor credential, same story again, and I check permissions against this open source permission system. Oftentimes we may want that with our query engine. We may have some LDAP system set up, or we may have some enterprise level group providers that we may want to integrate. The caveat with this is that this is a query specific translation with our permission system. So say you're using something like an Open Policy Agent or Apache Ranger. This query-specific translation is me asking for this machine user, what permissions does this machine user have with the permission system? And for one, I guess the biggest flaw to this is that there's, you go ahead and retrieve the data. The biggest issue is that there's implicit query engine trust. And that's something that gets a little hairy, especially when we talk about compliance and we talk about trusting and separating your users in your query engine. So it's important to kind of understand that if you're going to go down the client credential route, which in a compute-enforced permission base, then you're going to fall into this trap a little bit. Now, there's been discussions. Now, the rest of this is kind of a little bit theoretical. There's been discussions to go to more of a catalog-based permission system. So what would that entail? So instead of going directly to the permission system, the idea is, and I'll share the docs at the end, is that the REST catalog itself should have a spec to check what users or what permission set a user has. And in this case, not only a permission set for the super user, but for a specific user behind the scenes using the query engine. So how is this actually achieved? How do you actually achieve a situation where you have a user behind the scene and their credentials being checked? Well, it's two things. The first one is that we need to actually have a permission endpoint at the REST catalog level. That doesn't exist right now. Work is being done to establish that. I mean, until that's done, we'll have to keep relying on the permission system. And two, there was an RFC that was proposed in 2020, RFC 8636, which proposed using token exchange for these sort of purposes. And what token exchange does is it allows machines to act on behalf of users. So kind of explaining what token exchange is, the idea is that one, the REST catalog is going to have its own set of tokens or credentials using client credential flow, but it's also going to have and maybe leverage authorization code, the authorization code flow to get another token for the user. And once you have both of those tokens, and the audience of that token is designated as the query engine, you basically pass the client credential token and the user token to your identity provider. And once you're able to pass both of them to the identity provider, then the identity provider says, OK, you are the query engine acting on behalf of, say, Peter, Alice, Bob, whatever it is. And in that case, the RFC itself specifies that the query engine is behaving as the actor and the client is the subject. Now, this is a relatively newer type of flow in OAuth that hasn't even been extensively established yet. But in the Iceberg community, this has been heavily mentioned as a possible way to start delegating, specifically delegating through token exchange, because this is the right way to do it and to maintain security. As of now, there aren't many providers that even implement token exchange. Some of them, a couple open source ones do. But until that is resolved, it's kind of hairy to kind of have the purest form of security and provisioning over your query engine without having some sort of token exchange where you can act on behalf of another user. So that's kind of like the spiel of where we are now, and where we're going. So us at StarRocks, we also kind of implemented our own kind of solution for this delegation. Just kind of an intro to who we are briefly for a second. We're a real-time OLAP database. We try to meet your queries at sub-second scale. We try to tell you that you can eliminate denormalization. You don't need 100 cluster setup to run us. Joins are super fast, and we're columnar based. So naturally, us as a query engine, we were like, okay, this issue is kind of sitting, and we don't really like the problem that this is posing to our users. So on an upcoming version, our upcoming 4.0 StarRocks version, we took a hack at the token the delegation via token exchange, and we opted for using JOT token or JOT bearer token flow for this permission issue. So what does that entail? So instead of using a traditional token exchange, which, like I said, hasn't really been extensively implemented yet, the OpenID or the identity provider pre-signs a JOT token, and the user saves that file locally or connects it to their identity provider within the organization, passes that JOT token to the catalog provider. The permission system validates it, and then immediately we get some vended credentials that the user can then use on their object storage. So this is our approach. We're very excited that we're actively contributing to the future of delegation. The only thing that's kind of the missing piece here is the token exchange part, which we're hoping as we give more talks on this, the community kind of raises more awareness on it. And all the Iceberg developers, committers, contributors can kind of be a part of it. That is, here's some best practices, kind of run through these quickly. Try to keep a single source of truth. Keep your access direct. Centralize your permissions depending on your cloud provider. And depending on the cloud that you're in, try to be location agnostic. I don't want to go too over time. But if you're interested in us and what we do, if you're interested in some of the stuff I talked about today, feel free to join our Slack. There's a link also, I'll be sharing this deck afterwards, to the RFC page for token exchange, which folks are implementing slowly but surely. That's pretty much it for me. Thank you guys for listening to my talk.
If anybody has any questions, we have a couple minutes
if anybody
beforehand. And then at around 3:02 or so, if you want to take the questions and just kind of go into the hallway as well, if there's kind of more questions, we can do that as well. So the floor is open if anyone has a question. Otherwise,
did you have a question? Oh, yes.
If you want.
Oh, sorry.
There's a real question. You're just asking for the stuff.
Yeah.
So does that mean that basically the native OLAP tables now can be stored on the cloud storage?
Yeah, so you can have your data sitting in the cloud, but you get to still use our StarRocks native table format, even though your storage and compute is separated in the cloud. No, this has been the case for a long, long time now. The 4.0 feature is specifically for the delegation that I mentioned with the REST catalog. Our separation of storage and compute, we actually refer to this as shared data mode with compute nodes here. So these compute nodes basically act as stateless execution engines that actually run your SQL. Front ends are kind of the query planners. This has always kind of been a part of it. So that's irrelevant of 4.0, yeah.
Time for one more question.
Can you go one slide back? I didn't understand one part that.
Oh, sure.
Yeah, one slide back. Yeah. To me, this looks like a made-up problem because like the actor who's passing token as a user A, maybe the previous slide, is, I mean, it needs to know about the context of the user A, right? And why is it not passing automatically the token, and why is it passing query engine token? That part, I don't know why. It's kind of like weird problem to me. Like this is the right way to do this, and then why it has been implemented that the query engine is passing query engine token in the previous slide. It's kind of like a weird problem that, you know, that shouldn't have ever existed.
Yeah, oh, so are you saying the spec doesn't make sense, or are you saying?
If you go one slide back.
Oh, okay, sorry. Oh, even before this?
Yeah, here,
oh,
right, pass token as a super user, it's right there. Like if I was the security person who's gonna review this, I'm going to say like, why is it passing this? Yeah, why is it happening?
Yeah, so that's kind of the question that a lot of the contributors and the committers ask themselves too, because the whole idea with this is that, as I mentioned earlier, client credential is first just easier to implement. So, and the fact of using REST security and vended credentials is kind of a newer thing that just emerged as REST catalogs have expanded. So, the whole idea here is that if you're using a super user, you'd probably have an RBAC at the query engine level, or you may implement file level to complement that. So a lot of people go around this with introducing like a semantic layer at the query engine.
Yeah, that to me like a security implementation
like
at whatever that thing is, like I think that's the query engine is
that's
missing.
Starbucks, our logo.
Right, like because you already authenticated to the query engine, why are you passing super user? That's kind of weird to me, like from a security perspective.
Ideally, you know, what we'd like is you don't even have to use RBAC at the query engine level. You can just, as I was mentioning, with the new spec, you could just treat the user as who he is with the identity provider, and you could have one single source of truth for your identity, right? I mean, that would kind of circumvent this.
Yeah, that's the right way to do it.
Yeah, cool. Any other questions?
I think that's it. So thank you, everybody. Thank you, Ron. Cheers.
Cool. Thank you.